This is part 8 of the HVAC Schematics series. Now, the whole purpose again of this series is that you are able to start drawing the basic components and the basic circuit layouts and understand what you're drawing of an HVAC-R refrigeration system. We're starting with basic refrigeration systems because it is all line voltage. It doesn't have a lot of low voltage controls that we have to deal with transformers. Now, in this next diagram, we're going to basically build upon what we did in the first diagram, but we're going to take it a step further. Okay, remember, we had a cooling thermostat that was controlling everything. It was all 120 volt. We had a compressor, a CFM, okay, all 120 volt systems. Now, in our next diagram, the directions are: draw the following list of components for proper operation. All starting relays must be represented along with motor windings and other needed components. All must be fully labeled using starting relays instead of centrifugal switches. In other words, centrifugal switches can't be used in this diagram. Okay, EFM1 and EFM2 run all the time. Now, I have a cooling thermostat. I have EFM1, that's a split phase 120 volt. I have EFM2, that's a 120 volt PSC. Now this is where it starts getting interesting. CFM1, CFM2, compressor 1, compressor 2 are all 240 volts. Now, we do not use step-up transformers to increase the voltage and the amperage, because in a transformer, if you increase the voltage, you lower the amperage. There's no way this is going to work with a step-up transformer. So the reality is that this is two separate circuits, but there's a single component in this circuit that allows the inside 120 volt circuit to control the 240 volt circuit. So let's go ahead, and I want to start with the 120 volt circuit. Okay, so again, I have to have my line. I have to have a circuit breaker because that's required. Okay, and I have to have a neutral. Okay, so, and let's go ahead and make that just a little bit down lower. And I'm going to go ahead and label this. We're going to go ahead and label right there. We're going to label it right there. Line. And then I'm going to label my breaker. And I'm going to label neutral. Okay, and then the other thing I'm going to do is I'm going to label that this is 120 volts. Because now we're playing with two different circuits. And I want to make sure that we know that things are 120 volts. Okay, so going back to my directions, I have a cooling thermostat. The fans run all the time, so let's go ahead and take care of a split phase motor and a Psc motor. Now, if you did the same thing I did, which I encourage you to do, is you drew a symbol sheet that you can copy from. Okay, I have a Psc motor, and I'm just going to move that R down a little bit just to get it closer. Okay, and I also have a split phase motor. Now, my split phase motor here has no start component, so we got to remember that. So EFM1 is supposed to be a split phase motor. So let's go ahead and take care of EFM1 first. So I'm going to copy this one. I'm just going to copy it, and I'm going to toss it in over here. It's going to make it real big, but I'll take care of that here. Okay, and I'm going to put that over there. Now, to really make this work properly, because I can't use that centrifugal switch, I'm going to take this current coil relay. Don't have to have a capacitor with a current coil relay. I'm going to copy this, and I'm going to take it over. Okay, and I'm going to copy that over to there. So again, I'm going to put that in, line it up nicely. Okay, and I'm going to connect in the rest of my components here. First of all, I'm going to take and connect in my start components. Okay, then I'm going to kind of make sure I connect in my common. Now, I have to go on the bottom side of the breaker, but I'm going to show you how that's going to work out really nicely. Okay, so that is, let's call this EFM1, and I'm just going to go ahead and label that EFM1. Okay, that is a split phase motor, not using centrifugal switch. EFM2 is a PSC motor, again 120 volts, not using a centrifugal switch, because a PSC motor, remember, has a permanent capacitor in it. So if I just take this motor, copy it over here, okay, and put it in the right spot, I'm going to wire it in. I'm going to label it. Move the label so it's set. Okay, so now I have my motors. Now, I have to have a cooling thermostat. Thermostats are inside along with the evaporator fan. Okay, and the thermostat is going to have to control these 240 volt components that are on a separate circuit. So if you think back to one of the earlier schematics we did, we had a relay that's a coil and a set of contacts. Okay, well, in 240 volts, we still use a similar device. So I can have a 120 volt coil that's controlling two 240 volt contacts. That's called a contactor. It's a coil and two contacts, double pole contactor. So we start off with the same. We're going to use that cooling thermostat that I drew earlier. No sense in wasting something I already draw. I'm going to copy that. I'm going to come over here. I'm going to toss in my cooling thermostat. Okay. Then I'm going to take that relay coil. Again, I've already drawn a relay coil. I might as well use it. It's okay. I put it as part of this coil, so I'm going to just grab this. Okay, so I drew this relay coil. I'm going to pull it out and use it, and come over here. Again, when I paste it in, 9 out of 10 times it's bigger to start with, but we can take care of that. Okay, so I'm going to take my line voltage thermostat, 120 volt thermostat. I'm going to connect it into line. I'm going to come out of that thermostat. I'm going to come to my relay coil, and then I'm going to come back to neutral. Then I'm going to label everything. We'll label this CT. And remember, we have to label every coil. So the sequence of operation is breaker closes, okay? I have my evaporator fan 1 and 2, which run all the time. Okay, then my thermostat cycles on and off based on set point and energizes and de-energizes this cooling coil. That takes care of my 120 volt side. Now, for the line voltage, for the 240 volt side, I no longer have a line and a neutral. Okay, I have L1 and L2, same basic thing. But the biggest difference is I have to have a breaker on each leg. Okay, so we have my line 1 and line 2. Okay, I have to have a circuit breaker on each leg. So I'm just going to copy this. I'm going to copy this. And I'm going to put it in over there. And I'm going to label the breaker. And I'm just going to label CB because I don't want to confuse it with CB up here. Okay, if I wanted to, I could do a dotted line connection between both of these in this, or some sort of thing to show it's the same thing, that when these go, they'll go together. In this case, I'm not going to, okay? Some people, and I'm going to also mark this 240 because I want it very clear that this down here is 240 volts. Okay, so now outdoor in our 240 volt unit, I also have, I need a contact. Remember we talked about the contact? Okay, so this CC has to control something else. So let's go back over here to my parts list. Okay, and let's see what we got. Okay, I am going to use I'm going to move that start a little bit there. And I'm going to grab hold of that contact right there. And that is a normally open contact. Now, if I bring that in here, okay, I need to come over here and decrease that line a little bit. Okay, and I can do the same thing over here. I'll decrease that line. And give me another contact. Okay, and we'll label these two contacts CC. Now, this coil, when it's energized, will close these two contacts at the same time. So as long as the circuit breaker is closed, these two contacts close, and anything that's connected to these cables down here, anything that's connected to L1 and L2, which I still need to label. Okay, so let's label L1 and let's label L2. Okay, so anything connected to L1 and L2 will now get my 240 volts of power as long as it's underneath this. So, back to my directions. CFM1 is CSIR, CFM2 is a CSCR. Let's go ahead and grab those off the schematic diagram I already drew. Okay, so CSIR is that one right here. Okay, capacitor start, induction run. Let's go ahead and push that in here. Okay, now I have a CSCR that I have to have for CFM2. We're going to come over here. I'm going to grab this CSCR motor I have all here. Copy that. Come back over here, paste that. Adjust its size a little bit because I don't want to run out of room. Okay, and let's go ahead and wire in my condenser fans. So both of these come back to line 2 directly. And both come to the switch part of line 1. Okay, let's label them so we don't forget. Let's call this CFM1. And I'm just going to go ahead and off here CFM2 since I can't fit it into the motor like I did there. Okay, that takes care of my CFM1 and 2. Now, compressor 1 is a CSIR, compressor 2 is a CSCR. So again, we basically have the same components. So what do you say we just take we'll just take that, copy it, move it down, and I'm going to change the names of these. This is comp 1. And compressor 2. The whole point of this is that you just have to be able to show neat schematics. I don't need you to sit here and draw out every single symbol one right after the other. Make yourself a sheet as long as you've done it. You have to know how to draw these, okay? And you have to be able to recognize these. So don't copy it from someone else. Just make yourself a sheet as you go on through the course. And then you have a master that you can use. So this one we'll call normally open contact. Okay, so now we have a master that I can use, but let's go back over to our diagram here. So, sequence of operation. Breakers are all closed. Evaporator fans are running constantly on the 120 volt side. Cooling thermostat closes, energizes the CC coil. That coil will close through magnetic. There's no electrical connection. The coil will close the CC contacts. It's a double pole contactor. Okay, they'll close together. It's one unit. At that time, CFM1, CFM2, compressor 1, and compressor 2 will energize. Okay, this is the basic of a commercial refrigeration system where there's an indoor unit that's in the cooler and an outdoor unit that might be on a roof or behind a building or something like that. Okay, notice there's no transformer. We're still using line voltage, but we're using two different voltage sources, two circuit breakers, and two different levels of voltage. And the outside unit is going to be pretty heavy amperage. The inside unit will be lower amperage.